Assalamualaikum and hi everyone. It's me, SITI Ismail. Today, we are going to talk about thermophysics concept in the chart mailbox and how thermophysics help us understand the way heat and temperature affect the food and packaging inside the mailbox. Before we discuss the chart mailbox itself, let's first understand what thermophysics is. What is thermophysics? Thermophysics is a branch of physics that studies heat, temperature, energy, as well as how these quantities affect matters. It helps us understand how energy moves from one place to another and how it changes from in different physical systems. Thermophysics also connects the microscopic world of atoms and molecules with the microscopic properties that we observe, such as temperature change, heating, cooling, and insulation. In simple terms, it explains why objects become hot or cold and how heat is transferred between them. Now, let's look at some of the key concepts in thermophysics. The first key concept is temperature. Temperature is a measure of the average kinetic energy of particles in substance. The faster the particle move, the higher the temperature. For example, hot food inside a chart mailbox has particles moving more rapidly than cold food. The second one is heat. Heat is the energy transferred from a hotter object to a colder object due to a temperature. Temperature difference. In the chart mailbox, heat can move from the hot food to the surrounding air to the box itself. This process causes the food to gradually cool down over time. The third one is thermal energy. Thermal energy refers to a total internal energy of all the particles in a substance. It depends on both the temperature and the amount of material present. A larger portion of food generally contains more thermal energy than a smaller portion at the same temperature. And the last one is thermodynamic. Thermodynamic is a study of the relationship between heat, work, and energy. It helps us understand how energy is conserved and transferred within the system. In the case of chart mailbox, thermodynamics explain how heat is retained, lost, or distributed among the food, packaging, and surrounding environment. With this basic concept in mind, we can now explore how the thermophysics is applied in the design and performance of a chart mailbox. Now that we understand what thermophysics is, the next question is, what do we study thermophysics? Thermophysics is important because it helps us explain many phenomena that happen and we experience in our daily life. For example, it helps us understand how food is cooked, how refrigerators keep food cold, and even how weather change occur due to heat transfer in the atmosphere. Besides everyday applications, thermophysics plays a major role in many fields such as engineering, energy production, and environmental science. Engineers use thermal principles when designing machines, building, and transportation systems to improve efficiency and safety. Thermophysics also forms the foundation of many technologies that we rely on every day. Examples include engines in vehicles, air conditioning systems that cool our homes and classrooms, and power plants that generate electricity for our communities. Now, let's look at some of the major applications of thermophysics. First, heat engines and power generation. Thermophysics is used in heat engines, where thermal energy is converted into mechanical energy. This principle is applied in car engines, steam turbines, and power plants to produce useful work and electricity. The second one is refrigerators and air conditioning system. Refrigerators and air conditioner operate by transferring heat from a cooler region to a warmer region. Thermophysics helps us understand how these systems maintain comfortable temperature and preserve food. Number 3. Climate and weather studies. Scientists use thermal principle to study heat transfer within the Earth's atmosphere and oceans. This helps them predict weather patterns, understand climate change, and analyze environmental conditions. Number 4. Industrial manufacturing process. Many industries depend on controlled heating and cooling process. Thermophysics is involved in the metal production, food processing, chemical manufacturing, and many other industrial applications. Last one is renewable energy system. Thermophysics is also important in renewable energy technologies. Solar thermal system, geothermal energy plants, and other sustainable energy sources rely on thermal energy conversion to generate useful power. So, as we can see, thermophysics is not only a theoretical subject, but it's also a practical field that influences many aspects of modern life. Understanding its principle helps us improve technology, conserve energy, and solve real-world problems. Let's check the next slide.
Component of both. Firstly, how do systems work based on thermophysics? All mailboxes are fundamentally as a thermal isolation system. It is specially engineered to inhibit the flow of heat between the food inside and the internal environment. It works by creating a high resistance barrier that slows down the process of reaction thermal equilibrium with the surrounding, thereby keeping hot food hot or cool food cool for an extended duration.
This is an explanation on physical processes and related equations. So the first part is from the image given. We have a few main ideas. So the first one is foam or air insulation layer. So the physical process involved is conduction, and the K value here, which is can be seen as minimized K value. The K stands for thermal conductivity. So when we minimizing the K value, we directly reduce the amount of heat that escapes through the walls of the mailbox. So this is the related equations. Is the rate of conduction formula. Okay, so we move on to the second one is the airtight silicone seal. The physical process involved is convection. The silicone seal acts as a physical barrier with the fluid motion, as convection requires the movement of air to carry heat away and stop the air movement that stops heat transfer. So technically, the silicone seal traps the heat inside the chamber. Next, inner reflective lining. So physical process involved is radiation. We divide it into two: reflection and low emissivity. So the reflection is a reflective surface, like a metallic foil or a polished stainless steel. It does not absorb the infrared waves emitted by the food. Instead, it bounces them back toward the source. So for the low emissivity is a measure of how effectively a surface emits thermal radiation. The low emissivity surface is a poor emitter and a poor absorber, but a great reflector. This keeps the thermal energy trapped within the food chamber. So if we see the inner reflective lining and the airtight silicone seal directly connects to trapping the heat inside the chamber. So lastly, in a stainless steel chamber, so the physical process involved here is thermal energy retention. So we basically divide into two. So it comes with thermal mass and stability. So stainless steel and the food itself acts as a thermal reservoir because the chamber is hygiene and food safe and durable. It can safely hold a high amount of thermal energy. So the second one is stability. The material helps distribute heat evenly, ensuring there are no cold spots that would accelerate the cooling of the food. So as mentioned before, the third one, our related equation is the Boltzmann law, and the fourth one, the related equation is specific heat capacity. So that it is.
The outcome or effect observed from the system: reduce heat loss by conduction. Food remain warm for a longer period compared to ordinary containers. Second, reduce heat loss by radiation. Less heat energy is lost to the surrounding. Third, minimize heat loss by convection. Heat is retained inside the mailbox, maintaining the food temperature. Improve the temperature retention. The mailbox maintains a stable internal temperature. And the last one is higher energy efficient. This reduces energy consumption and improves user convenience.
In conclusion, this child mailbox applies the principle of thermophysics to maintain food temperature effectively. By reducing heat transfer through the conduction, convection, and radiation, the system is able to retain heat for a longer period, improve temperature stability, and increase energy efficiency. This project demonstrates how thermophysics can be applied in everyday products to solve practical problems and improve user convenience.